This problem is based on group theory. The asymmetric stretching mode of the H2O is shown below. The molecular plane is YZ and the symmetry axis is Z. The vibration transforms as the irreducible representation dash. Water molecule is given here, and basically they have given the asymmetric stretching. One side it is stretched more compared to the other side. This is referred as asymmetric stretching. Here the plane of the molecule or the plane of the paper is YZ. This is the principal axis. This is Z. So this should be Y. Axis perpendicular to the plane of the paper, that is towards us, will be X. Now the vibration transforms as the irreducible representation. We have to find out. This particular asymmetric stretching represents which one of the irreducible representation. There are 4 symmetry operations in C2V point group. In fact, the character table for the C2V point group is given in this problem, but for simplicity I have not mentioned that. These are the 4 symmetry operations. Now I am going to carry out these symmetry operations on this asymmetric stretching mode. If I get the same structure, I am going to give 1. If I get different structure, I am going to give -1. First, let us go for E, identity. We are not doing anything on the given structure. So the structure will remain as such. So I will get the same structure. So 1. The next one is C2. Through this axis, I rotate this stretching mode by 180 degree. When I rotate by 180 degree, this hydrogen will go the other side. This will come here. I will get different structure. So I give -1. Next one, sigma xz. X is perpendicular to the plane of the paper. So it will be like this. The plane xz will be here. When I reflect the given structure, this hydrogen will go the other side. This will come here. I will not get the same structure. So here I will get -1. Finally, sigma yz. Yz will be the plane of the paper. I place the mirror in the plane of the paper. The structure will be same. Now let us go to the character table. I have got these characters 1, -1, -1, 1. What about the irreducible representation? It is B2. Even if it is not given, you are expected to know the character table for the simplest molecule. For C2V and C3V point group, you should know the character table. You have to memorize, you have to remember the character table for C2V and C3V point group. This is another problem based on character table. Character table for the point group C2V is given, so we can find the character table. The reducible representation corresponding to the 3 translational degrees of freedom, that is tau trans, is. The translational and rotational degrees of freedom are identified based on these letters. Here I have X, Y and Z. Basically these are translational degrees of freedom. X, Y and Z. Rx, Ry and Rz are rotational degrees of freedom. Let us consider only translational degrees of freedom A1, B1 and B2. We have to add the characters in the irreducible representation A1, B1 and B2. 1 plus 1 plus 1, I get 3. Here all the 4 options, the first character is 3, so I need not bother much about that. Second one, 1, -1, -1. So the second one will be -1. Third character will be 1, 1, -1. So it should be +1. So this particular option satisfy. So what I get is these characters. So this should be the correct answer. Instead of translation degrees of freedom, say rotation degrees of freedom is asked. In that case, you have to add A2, B1 and B2, Rx, Ry and Rz. So in that case, what you get is 3 minus 1 minus 1 minus 1. So that option is given here. 3 minus 1 and minus 1, that is rotational degrees of freedom.